Day 651 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3714, longest balance substring 2. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a string S consisting only of the characters A, B, and C. A substring of S is called balance if all distinct characters in the substring appear the same number of times. Return the length of the longest balanced substring of S. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So before we get into these examples, let's make sure we know what a substring is. It says a substring is a contiguous, non-empty sequence of characters within a string. So what that means is a substring is just a string within a string, right? But the characters have to be contiguous, meaning they have to be lined up next to each other already. We can't just take this A, then delete this B, then take this B and delete this A and take this C. No, the elements have to already be next to each other, and we're just trying to create a substring from this string that is already created, right? So this might be a substring, this might be a substring, this might be a substring. A substring is just a string that we can create inside this string that we already have. So now that we know what a substring is, let's take a look at example 1. So in example 1, our input S equals a string A, B, B, A, C. Output is 4, meaning the length of the substring that we create, where all of the characters appear exactly the same amount of times, will be 4, right? So it's either going to be this or it's going to be this, right? Because that's the only way we can have a count of 4 in our substring. Now the explanation lets us know it's this right here. It says the longest balanced substring is A, B, B, A because both distinct characters A and B each appear exactly twice. So in this case, we could see this substring right here is A, B, B, A. So A appears 2 times, B appears 2 times. That means it's balanced. Now say we took this substring right here, right? Or it could be this. This isn't balanced because B appears twice, A appears once. That's not balanced. Say we did this substring. This has a count of 4. B appears twice, but A only appears once and C only appears once, so it's not balanced because all of the characters don't appear the same amount of times. Whereas this right here, this is the longest, right? We want the length of the longest balanced subarray or balanced substring of S, and this right here is the longest balanced substring of S, right? We have 2 A's, 2 B's, and has a count of 4. If we just did this, this is a balanced substring, but it's not the longest. It only has 1 A and 1 B. So since it's not the longest, we're gonna go that this only has a count of 2, whereas this has a count of 4, which means this is longer, which means this is the one that we're going to return because once again, we want the longest. Now, just in case that didn't make sense to y'all, let's take a look at example 2. So in example 2, our input S equals a string A, B, C, C. The output is 3. And before we even look at the explanation, we can see this right here is the longest balanced substring. Why? Because A appears once, B appears once, and C appears once. Now let's look at the explanations to see if that's right. It says the longest balanced substring is ABC because all distinct characters A, B, and C appear exactly 1 time. So boom, we already know this is the longest balanced substring we could create. This is a substring, but it's not the longest. This has a count of 2. And this is a substring, but it's not the longest. This only has a count of 1. We want the longest, and in this case, the longest is this. Now, this is also a good example to explain why contiguous is important, right? Because say we deleted this B. If we deleted this B, then we'd have 2 A's and 2 C's, and that'd be a count of 4. And that'd be longer. However, that's not contiguous, right? Because we need this B. We can't delete any characters for it to be contiguous, right? So all of the characters have to be already lined up next to each other in order. So, and we're just continuing to expand the subarray without deleting anything, right? So that's just an example of what contiguous means. So let's take a look at example 3. In example 3, our input s equals a string ABA. The output is 2. So just by looking at this, we can see that this is a balanced substring. This is a balanced, this is a balanced substring with a count of 2. This is a balanced substring with a count of 2. This right here has a count of 3, but it's not balanced, right? So it says one of the longest balanced substrings is AB because both characters A and B each appear exactly one time. Another balanced substring is BA. So once again, we need the characters in the substring to only appear once, right? So, or excuse me, not appear once, appear the same amount of time. So once again, we could do this substring or we could do this substring, but either way we look at it, the output would still be 2 because each substring only has 2 characters in it. Boom, y'all. So now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. It's a little bit of code, so get ready for that. Now, first thing we're going to do is we're just going to create a struct to represent a balanced state in the string, and it's going to be hashable so it can be used as a dictionary key. So we'll come outside of the function, still inside the class, and we'll create a struct. So we'll say struct, call it key, colon, it's going to be hashable, open up the brackets, and we're going to say let type, colon, that's going to be an integer, and this is going to indicate which type of balance we're tracking, ABC, AB, BC, etc., right? So then we need to get the difference or count used for this balance type. So we'll come right here underneath this and we'll say let x equal, that's going to be an integer. And we also need another difference or count for the balance type. So we'll say let y, that's going to equal integer as well. Boom. Now let's get into this function, this main function right here. Now, first, we're going to create a dictionary to store the first index where a given key state was seen. So the key is going to equal a balanced state, and value is going to be the index in the string where this state occurred. So we'll declare a variable called prev, say colon, it's going to be a dictionary of integers. Once again, the key is going to be the balanced state, so that's that integer, and the value right here is going to be the index in which this in the string where the state occurred. So this is going to be integer as well, and we could initialize it with a blank dictionary like this. Boom. Then we need the running counts of A, B, and C in the string so far, so we could keep track of that with a variable. So we say var A equals 0, sorry y'all, 0, comma, B equals 0, sorry y'all, equal white space, and C equals 0. Boom. So that's once again going to keep the count of A, B, and C in the string so far. Boom. And this right here should be a comma, not a period. So let me just make sure that's right. Boom. Now we need the maximum length of a balanced substring that we found so far. So we could just declare a variable called ands. We'll set that equal to 0 to start. And now we're going to generate all possible balance states for the current counts. So we're going to create a func called keys. Put the parentheses, it's going to return, sorry, I was going to return an array of key from this struct up here. And we're going to open up this bracket. Then we're going to come inside this bracket, open up some square brackets. And for type 0, the difference between A minus B and A minus C, meaning all three are balanced. So we're going to say, let's open this up. Remember, y'all, this is inside some square brackets, which is inside this bracket as well, just so you don't miss that. So we're going to say key, open up the parentheses, type, colon 0. We're going to say comma x, colon, that's going to be A minus B. Then we're going to say comma y, colon, that's going to be A minus C, equal white space, y'all, equal white space. Boom. Now for type 1, the difference is going to be A minus B, and we're going to track C separately as A equal to B. So we're going to say, come right here, we're going to say key, open up the parentheses. Or matter of fact, we're going to have to do 6 of these. So let's just copy and paste this 6 times. Boom. So we'll say C. So just so we can move a little faster. 1, 2, 3, or that's 4, 5, 6. Boom. So right now, and I'm gonna put a space between the ones that we've done so we don't do the same one twice. Boom. So this is gonna track the difference between A minus B again, and once again we're gonna track C separately. So this is gonna be type 1, or we could just change the type now. 2, 3, 4, and 5. Boom. And actually, it should be 6. So we're going to need one more. Copy and paste it one more time. Boom. Okay, now we're looking at 1, though. So 1, we're going to track A minus B. So we can keep that. And then we could just put C. We could get rid of this A minus, and we're tracking C by itself. Boom. So let's bring that up so we know we did that. And then boom. Now we're on type 2. Type 2 is going to be the difference between B minus C, and we're going to track A separately. So this time, we're going to change this right here to B minus C, and we're going to track A by itself like this. Boom. Then we did that, so let's bring that up. Now we're on type 3. Type 3 is the difference between C minus A, and we're going to track B separately. So we'll say change this to C minus A, and we'll change this to B. Boom. Did that. Let's bring it up so we know we did it. Now we're on type 4. Type 4 is going to track B and C only. A will be ignored. So we'll change this to B, X to B, change Y to C. Boom. A going to be ignored. So we can bring that up. Now we're on type 5. Type 5 is going to track C and A only. B will be ignored. So we're going to change this to C. And we are going to change this to A. And boom. Now we can bring this up. Now we're on, and this should be type 6, y'all. So now we're on type 6. Type 6 is going to track A and B only, and this time C will be ignored. So we're going to come right here. This will be A. So we get rid of this. This will be C. No, this will be B. Sorry, y'all. This will be B. Boom. C will be ignored. Bring that up. Boom. So now we have the keys. Now we're going to initialize the dictionary with the starting state at index -1, and this is going to allow substrings that start at index 0 to be counted correctly. So we'll come underneath this right here, underneath that func. We're going to say for key in keys, put the parentheses, come outside of that, open up the brackets. We're going to say prev square bracket key. Come outside of that, we're going to say equals -1. Boom. Then we're going to iterate over the string with index. So we're going to come underneath this. We're going to say for, open up the parentheses, I, comma, ch, come outside of that, n, s dot enumerated, open up the parentheses, open up the brackets, and we're going to update the running counts based on the current character. So we're going to say if ch equals a string A, we'll come outside of that, open up the brackets, and we'll say A plus equals 1. Boom. Then we're going to come underneath this. We're going to say else if ch equals string B, come outside of this. We're going to open up the brackets. We're going to say B plus equals 1. Boom. Then we're going to come underneath this. We're going to say else. We're going to open up the brackets. And we're going to say, sorry, y'all, we're going to say C plus equals 1. Boom. Then we're going to check all balance states for the current counts. So we'll come underneath this, and we are going to say for key and keys, put the parentheses, open up the brackets. We're going to say if let idx equals prev square bracket key. Come outside of that, we're going to open up the brackets, and if we've seen this state before, then the substring between index 1 through I is balanced. So we can say ans equals max, open up the parentheses, ans, comma, I minus idx. Boom. Then else, we come right here, we'll say else So otherwise, we'll store the first occurrence of this state by saying prev square bracket key equals I. Now we need to return the maximum length of the balanced substring by coming right here. And we're going to say return ands, y'all. That should be all she wrote. Let's give it a run. And we have an error. Oh, so these right here, we need to put our commas. We just copied and pasted with no commas. What was I thinking? I don't know. So let's just put these commas right here. And now let's run it again. See if that does the trick. Okay, let's see what we got here. So this should be, sorry y'all, this should be colons, not equal signs. So let me just fix this. Let's run it again, see if that did it. Hopefully that, nope. Okay, so let's see where we're at. This should, I think this should be a, oh y'all, this is it right here. This should be a key. Sorry, not an integer. So let's change that to key. And now let's run it again, see if that did the trick. And it's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. And look at that, y'all. 1,781 milliseconds beats 50% of users. Not too bad. Not too bad at all, y'all. So with that being said, we'll focus on getting these numbers up as we continue down our LeetCode journey. But right now, we just want to be able to solve the problem that is presented to us, and I feel like this is a good solution for that. So with that being said, make sure you get one more look at the code. This is the top part. This is the middle. This is the other part of the middle. Well, actually, that's the bottom, y'all, right there. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.